All right, guys, so here's our first YouTube video of the year. I know it's been a while, so what we're going to do is we're going to go over the semester exam review. So what we have in front of us is, at this point, a table with some pictures and the list of terms in a word bank. So what we're going to do is we're going to fill in the terms. I will explain the definitions, but it does say to fill in your own definition. This is a definition that will help you define it. So I will explain it. We'll discuss them in class on Monday, but you're going to want to go ahead and come up with your own definition as well. All right, so let's go ahead and get started. So our first picture, this one right here, this is going to be an altitude. So that's our altitude. Now you don't have to write altitude of a triangle. I mean, you're looking at a triangle. It's clearly an altitude of a triangle. Now, an altitude of a triangle is a segment that goes from a vertex to the opposite side that is perpendicular to that side. Okay, so it is a segment from vertex to opposite side and is perpendicular to the side. All right, write your own definition. If this one works for you, that's fine, but I would recommend coming up with your own. All right, so the next one we have is a mid-segment. You can tell it's a mid-segment because it is a segment in the triangle, and it goes from one midpoint to the other side's midpoint. So you can tell it's a midpoint because you have your tick marks. So there's two tick marks there, so this is the midpoint, and one tick mark each here, so those are both midpoints. All right, so our next picture is also perpendicular, and we can see that here, this line is going down to the midpoint. So that means it is bisecting that line. So this is our perpendicular bisector. And a perpendicular bisector is just a segment, line or ray, that bisects a side and is perpendicular to that side. Easy enough. All right, our next picture, we have a segment that is cutting an angle in half. So we have a segment, and it could be a line or a ray that essentially cuts. This is an angle in half. So that is going to be our angle bisector. Remember, angle bisectors cut angles into two equal pieces, so they are congruent. And finally, we have a line segment that is going from a vertex to the midpoint. So a segment from vertex to midpoint. and that is called a median. These are all terms we did go over recently. Just in case you forgot, though, they are there for you. So those are our vocabulary words that we had from our triangle unit. Remember, our semester exam that we're having is cumulative. That means it's covering everything. So next two questions are going to be about conditional statements. So number 2 has statement A. If you've read The Hunger Games, you've heard of the character Katniss. And statement B says if you have not read The Hunger Games, then you have not heard of the character Katniss. So we notice that we have our P and our Q, and we still have our P and our Q. So they're still in the same order. So we haven't changed the order, but we did negate them. We just said they are not true. So if they're both not true, that is our inverse. We didn't flip them, we just negated them. So that's the inverse. All right, number 3 says, given the conditional statement below, construct the following. If you attend Lee High School, your school mascot is a volunteer. So we have our biconditional statement and our contrapositive statements that we're going to make. So remember, our biconditional statements are going to be our if and only if statements. Remember, those are going to have to be true forwards and backwards. So if P, if and only if Q. And our contrapositive statements are both switched and negated. So if not Q, then not P. And I know that squiggle that we've used here means similar with triangles, but remember when it comes to conditional statements, it means not. So I'm sorry it's becoming confusing. That symbol's going to mean a few different things a few different times. So let's go ahead and write these phrases. If you attend Lee High School, your school mascot is a volunteer. What would be the biconditional statement? Go ahead and pause and think about that for a moment. If you said you attend Lee High School if and only if your mascot is a volunteer, you would be correct. Now, is that a true statement? Well, I mean, if we're saying Lee High School as our Lee High School, then yes. Because if you attend Lee High School, your mascot is a volunteer. And in San Antonio, if your mascot's a volunteer, well, then you attend Lee High School. Because as far as I know, we're the only school that has a mascot that's a volunteer. It's a little unusual. All right, now contrapositive. Not Q, then not P. So remember, our P is if you attend Lee High School, and our Q is your mascot is a volunteer. So go ahead and pause it. Think about what you think it's going to be. If you said if your mascot is not a volunteer, then you do not attend Lee High School, you are correct. And I would say that's probably true because if your mascot's not a volunteer, well then of course you don't attend our Lee High School. Now of course that does only apply to Lee as in the legacy of educational excellence. There are other Lee High Schools. Okay, so keep that in mind. All right, let's move on to the next page, number 4. So we have a picture here. We can see a line segment DE. It is connecting 2 points, point D and point E. And we can see that we have BE marked with 1 tick mark and EC marked with 1 tick mark. So this is a midpoint. And we have BD marked with 2 tick marks and DA marked with 2 tick marks. So D is also going to be a midpoint. So what that tells me is that DE is a midsegment. And it wants us to find the lengths of DE, BE, and AD. So as you all know, the first thing I want you to do is label your pictures. So let's go ahead and do that real quick. All right, now as you can see, I've labeled my picture with all the side lengths that I've been given. I have AB marked as 13 centimeters, BC marked as 11 centimeters, and AC marked as 14 centimeters. So what is the length of DE? Well, I see DE is the midsegment. Now remember, the midsegment is 1/2 the length of the line that it's the side that it's parallel to, so the base. So all we have to do is take our base, which is AC, and divide it in half. So DE is going to be AC divided by 2. So that's going to be 14 divided by 2. So DE is 7 centimeters. So let's go ahead and label that in our picture as well. Always label your picture as best you can. And then we have, what is the length of BE? Well, BE is half of BC. So again, we're going to put BC over 2, and BC is 11. And you can leave it as 11 over 2. You know I like fractions, but we can also go with a decimal, and so that's going to be 5.5 centimeters. And finally, it asks us, what is the length of AD? AD is also half a length. It is half of line segment AB. So we can take 13 and divide it by 2. You can leave it as 13 over 2, or look at for 6.5 centimeters. So just keep that in mind. If you're not sure, just run them through and double check to see if your fraction and your decimal match. So let's go ahead and move on to number 5. Now, number 5 shows us a picture of an isosceles triangle. What do we know about isosceles triangles? Well, we know isosceles triangles have two congruent sides, which we can see here. We have a side that's 26 centimeters and 26 centimeters. And anytime we have a triangle that is isosceles, our base angles are also congruent. So if the sides are congruent, the angles that are opposite are also congruent. So that means this angle is also 74 degrees, so that's pretty easy. So x, y, z. X, y, z is 74 degrees. But we do need to find the last angle here. How do we find the last angle? Go ahead and pause your video and see if you can figure it out. Now, I really hope every single one of you came up with 32 degrees, because that's what angle x, z, y, or y, z, x is. What we did is we added 74 and 74, because that's what our base angles are, and then we subtracted 148 from 180, and we got 32. So moving right along. All right, number 6, it looks like we forgot to mark some tick marks, but it does look like this was meant to be a mid-segment. So in this case, I'm going to go ahead and mark the tick marks, and we're just going to work with it as if it is. Okay, so we're going to mark our tick marks. And then we're going to solve for x and find the length of AB. Now, finding the length of AB is probably easy enough. All we have to do is take 34 and divide it by 2. So let's do that first. What is 34 divided by 2? If you got 17, good job. 34 divided by 2 is 17. So now we know the length of AB. AB is 17. So if we need to solve for x, all we're going to do is take 3x minus 1 and set it equal to 17. So what I'm going to do now is I'm going to solve for x by first adding 1 to both sides. And I'm going to get 3x equals 18. And then what I'll do is I will divide by 3, because I have 3 times x equals 18. And that is going to give me x equals 6. So if you got x equals 6, congratulations, you did this problem correctly. All right, number 7, Jeremy plotted the following points on a coordinate plane. A is 2, -1, B is 5, 8, and C is -8, 0. And they want us to find which kind of triangle we have here. So let's go ahead and plot those 3 points first. So we have 2, -1, and we're going to go ahead and label that point A. We have 5, 1, 2, 3, 4, 5, 8, 1, 2, 3, 4, 5, 6, 7, 8. And let's go ahead and label that point B. And then point C is -8, 0. 2, 3, 4, 5, 6, 7, 8. So now we have 3 points. Let's use our straight edge and connect them. All right. So let me go ahead and fix this one. There we go. Now we can look at this one and we can see that it's obtuse. That definitely isn't a right angle. Those aren't acute. So if that biggest angle were a right angle, it would go like this. So we can see that's not a right angle. To be 100% certain, we should probably measure it. So if you want to use a protractor on the test, that's fine. You can use a protractor. But it's obtuse, so let's go ahead. And we wouldn't have equilateral and acute. That's not how we call that. We call it equiangular. All right, so let's see. So we have one. And it looks like it's going to be scalene, because those are not the same size. I also forgot to label point C. Sorry about that, guys. So it's going to be scalene and obtuse. All right, let's go ahead and move on. All right, it says draw the midpoints of segment MN and NP, then connect them to form a midsegment. If segment MP is 8 centimeters long, what is the length of the midsegment? So we're not going to have anything perfect. This is 8 centimeters. We are basically just going to eyeball it. All right. And I'm going to use a straight edge so that my line is reasonably straight. Not perfect, but reasonable. Okay, not perfect, but reasonable. And again, I can't tell for sure if that's a perfect mid-segment. However, this is math class and it doesn't necessarily have to be perfect. Remember, what makes math accurate is labels. So if I make these labels, therefore it is now a mid-segment. I made my tick marks, it's a mid-segment. Now remember, a mid-segment is half the length of the base. So if MP is 8 centimeters, then this new point, let's go ahead and call it AB, is 4 centimeters. Okay. All right, let's go ahead and keep going. All right, we have used the figure below to answer questions 9 through 11. So question number 9 says, what is the equation for line B? Well, first we're going to need to find the slope and the y-intercept. So let's go ahead and do that. Now look at number 10. It says, what is the slope of line B? So let's go ahead and first find the slope of line B. It makes so much sense to go ahead and do that. So let's look at it. It looks like it's probably negative, but just to be certain, let's draw our slope man. I know he's sad, but we like our slope man. So yes, it is a negative slope. It matches his right eyebrow. Well, it's his left, our right. So we're going to put a negative. And we can see that it goes up 1 and over 1. Let's go ahead and go on the top. It doesn't really matter, but up 1 and over 1. So it's a -1 slope. So we know we're going to have y equals -x. And then we're going to ask ourselves, what is this point right here where it intersects the y-axis? Well, it's -1, -2, -3, -4, -5, -6. That is 0, -6. So that is going to be y equals -x minus 6. All right, so number 11, what is the equation of a line parallel to line A? Now, a line, that's a key word there. So what that means is it doesn't matter if your line matches my line, so long as it is not line A and has the same slope. Remember, parallel means they have the same slope, but different y-intercepts. So first of all, this one has a y-intercept of 1, 2, 3, 4. That is 0.04, okay? And the slope, let's go ahead and do that. So I'm going to go ahead and erase that point. Take just a minute. That's 0, 4. And we're going to go up 1, 2, 3. So that's up 3. So y equals, and we know we're looking for an m equals 3 over 1, 2, 3, 4, 5. So as long as you have a slope of 3 over 5, you can write any y-intercept except 4. So y equals 3 over 5x plus 5, y equals 3 over 5x, y equals 3 over 5x minus 2. It doesn't matter so long as it's not the same slope. All right, moving right along. All right, it tells us that triangle MNP is scalene. Draw median PS. So that means our line segment is going to go from here to about, let's just say there. So our midpoint will be S. We need to mark them congruent. And you do not necessarily have to use a straight edge. I'm just doing it to make it pretty. So is it perfect? Probably not. But what it is accurate because it is marked. So we have MS is congruent to SN. So line segment MS is congruent to SN. All right. Now it asks us that MSP plus NSP. Now we can see that those are a linear pair. So that's going to be equal 180 degrees. And they are supplementary. Additionally, they're a linear pair. Linear pairs are always supplementary, but not all supplementary angle pairs are linear pairs because they have to be also adjacent. Two angles can add up to 180 without touching. All right, using number 13, using the figure below, find the measure of the unknown angles. So the first angle it wants us to find is WYZ. WYZ, remember we're going to trace it, WYZ. It tells me that angle WYX is 29. So this one's going to be 180 minus 29 because they are a linear pair. So if I take 180 and subtract 29, I am going to get 151 degrees. Okay, next one it wants us to ask is XWY. Now we can go ahead and add 29 and 90 together. So we're going to take 29 degrees plus 90 degrees, and that's 119. 180 minus 119 is equal to 61. And then finally we have VWY. Now there's two ways to find that one. We could just take 180 minus 61. That would be the easiest way. And we actually do know it's already there, 119, because we already added up the remote interior angles. Remember this right here? That's an exterior angle. An exterior angle is equal to the sum of the remote interior angles. Remote means it's not adjacent, interior means inside. So if we have an exterior angle that's adjacent to our triangle, we can add together the remote interior angles to get the exterior angle. All right, which of the following equations would produce a graph that is perpendicular to the one shown below? All right, so if you look here on our answer choices, we have 3 over 5x, negative 5 over 3x, negative 3 over 5, and 5 over 3x. So what we only thing we need to do is figure out what the slope is of this line and figure out what the perpendicular line would be. Remember, perpendicular lines are opposite reciprocals. What that means is they have opposite signs. So if it's positive, the other would be negative, and vice versa. If it's negative, the other would be positive. Reciprocal simply means that if we have 5 over 3, if we have 3 over 5, it would be 5 over 5. So what we're going to do is figure out which one matches our line and go with from there. So let's go ahead and see what we've got. All right. We have 1 point here and 1 point here. So it looks like we have 3 over 5, and it is positive. So we definitely want to eliminate the positive ones. And so our answer is B. It is going to be the only one that is the negative reciprocal of the line that we've been given. Since our slope was 3 over 5, we definitely had a slope of negative 5 over 3. And it didn't matter what the y-intercept was at all. Okay, now moving on. It says number 15, put the triangle side lengths in order from least to greatest. What we need to do here is remember that our side lengths are opposite the angles. So the biggest angle is opposite the largest side, and the smallest side is opposite the largest angle. So we need to figure out what our third angle, angle P, is first. So first thing we're going to do is add 85 plus 28, and we're going to get 113. We're going to take 180, subtract 113, and we get 67. So this one is 67 degrees. So what we're going to do, it says least to greatest. So we're going to find our smallest angle and go straight across. So that's NP. Find our next smallest angle, which is 67. Go across. That's MN. And finally, our last angle, go across, and that's going to be MP. Enough of that. All right. Number 16, classify each pair of linear equations as parallel, perpendicular, or neither. All right, so number 1, the slopes are 3 over 4 and 4 over 3. So since those are not opposite signs, it can't be perpendicular. And because they are not the same, they can't be parallel, so they would be neither. All right, number 2, we have negative 1 over 5 and negative 1 over 5. Those are the same slope, so they are parallel. Number 3, negative 1 over 3 and positive 3. Those are opposite signs, and if we think about 3 as 3 over 1, it is a flipped fraction, so they're perpendicular. And finally, we have 3 over 2 and negative 2 over 3. So again, perpendicular. Okay. All right. So number 17 says that BC is the mid-segment. What is the length of BU? Well, we know that mid-segments go from midpoint to midpoint. So this and this are congruent. So if the whole length of US is 12, all we have to do is take line segment US, divide it in half. So that's going to be 12 divided by 2. And so therefore BU is also going to be 6, just like CT, CU, and also SB. All right, guys, so we're going to take a break right there, and we will come back in just a few moments. You can check out video number 2, and we'll see you shortly.